So, gravity part 2, continuing the talk from before, just because I have some time. And I realized by listening back into what I was saying and everything that the word was buoyancy that I was looking for the whole time. Buoyancy. Okay, buoyancy is part of the reasons, of the influences that result into what we sum up as gravity. So it's funny in that short, what was it, 30 minutes or what, in which Buzz Aldrin was talking to the child. You can watch the video, it's on YouTube somewhere. Buzz Aldrin, astronaut, talks to a child. The child asks questions, and then it comes to the point of weightlessness in space. And it's funny because just to fit that narrative, he says there is no gravity. But like 10 minutes later, he says, what keeps the moon there? Gravity. So it's just funny how they contradict themselves within the very same speech, sort of, within 30 minutes. So just to fit the narrative of weightlessness in space, which obviously is a complete hoax, he says no gravity in space, and then he comes to the moon and talks about what is true, what keeps the moon there, gravity. But to be exact, it's buoyancy. And I guess that's also why it's called buoyancy lab and not gravity lab. That's where the ISS replica is, in that water pool. It's called buoyancy lab, not gravity lab. What keeps the moon there is buoyancy, but of course we sum it up as gravity later on. But buoyancy is the same as a buoy, it's called, I guess. In German it's called Boje, but in English it's buoy probably, that floats on the water, simply because of densities. Densities create buoyancy. There's an object, it's surrounded by a medium or by two mediums, as in the case of a boat. It's surrounded by water underneath the boat, and it's surrounded by air from the bottom up, okay? So there are different mediums, they have different properties, and that results into a condition or whatever, what you want to call, for example, buoyancy, that the boat floats on top of the water. That's buoyancy, that's gravity, and the same thing applies to the moon. The moon floats up there, okay? Doesn't float on water, but floats on other gases, because there is a gas inside the moon that keeps the moon there, okay? The moon is not solid throughout. There must be a gas inside, and it's acting just like a helium balloon, but it's not helium, the gas. I'm pretty sure it's something like hydrogen. Must be hydrogen or something inside the ball that keeps the moon there, the ball of the moon, okay? If we consider the moon spherical and a ball. And maybe the moon is no ball, I don't know. To me it looks like a ball. Maybe the moon is a field. Maybe the moon is the firmament, who knows? But saying that the moon is the firmament to me doesn't make much sense, because I mean, why would we always then see kind of the same, like the same spot? You know what I'm saying? But back to gravity. not speculating about the moon now, because you get into territory where, yeah, there is a lot of speculation and assumption. But what we do know is that why the moon is there is because of gravity. Okay? Because of the properties of the moon, it floats up there. And it's surrounded by a medium. Just because the medium is not air and the medium is not water doesn't mean that there is nothing up there. Okay, it's near vacuum, there is still something. It's just lethal to humans. Humans cannot be there, but other objects can be there. Plasma, you know, high energized gases, that's plasma. So gravity. Let me just cross that road quickly. I'll be back in 5 minutes. No, just kidding. 1 or 2 minutes. So, gravity is not a force of itself, it's just a term with which we describe a sum of forces, a result that we're observing after material interacted with each other. You have materials with high density, you have materials with low density, and so they seek its places in this universe where, according to their own properties, everything is in balance again. So that's why, for example, air bubbles rise up through water. Okay? And one interesting observation about air bubbles rising up through water is that the bigger these air bubbles become, the less spherical they are. And that's what I talked about in the first live about gravity, is that gravity, that is not a force of itself, but a sum of forces, a play of forces that result into a physical result. For example, creates a spherical shape of an air bubble in water, but only when that air bubble is small enough. The moment that air bubble gets bigger, the less spherical it becomes. And the same with water drops in air. So we're turning it around now. Now we have the medium air and we have water drops. Gravity is not a force of itself in the middle of that water drop. Gravity is just a sum of forces that come together from outside of the object. Okay? You have the air pressure that surrounds the drop of water. You have water surface tension. Okay? The bigger this whole thing gets, the bigger the water drop gets, the less spherical it becomes. Okay? There's the truth. Same with air bubbles in water. Small air bubbles in water are pretty much spherical. It depends on the volume. the bigger they get, the less spherical they become. And you can see that in videos, for example, where people are diving, scuba diving or something, and giant air bubbles are rising through the water upwards back to the air because it seeks its own balance. Air seeks its own balance. You can see that they become more like a jellyfish. Okay? Not spherical at all, just like half spherical. Why is that actually happening? Because there's water pressing from the sides and from below into the air bubble, pushing it upwards. That destroys the sphere, okay? That cannot destroy the air, obviously. The air sticks together still somehow, but it reshapes the air bubble, turning it from kind of spherical into less spherical. And most likely the air will separate into smaller bubbles. Okay, and then they would become again more spherical because the volume decreases. So if anybody says that gravity is the reason why we live on a spherical ball, has no understanding of science, has not observed reality. Okay? Because Earth is a giant, big object, giant mass. If gravity makes everything into a sphere, why are stones not spherical? It's rare to find spherical stones. These stones are actually created by people, manufactured with machines or tools. And that's why it's elusive. That's why a lot of people are living visually in illusions, or they are being led into illusions visually by these creations. And they mistake the people's creations for reality. Because in nature, it is very, very hard actually to find a spherical shape of anything. And the reason why, for example, a stone is dense and there's a lot of material stuck together is because of other forces within that stone. Okay? So there is not a force from the middle of that stone that just draws more stone to itself. In fact, during the course of time, a stone actually decreases in volume. It does not draw things to itself just because there is a high mass. And if you have a lead ball, a giant lead ball, it doesn't draw things to itself, although it's a giant mass. Lead is very heavy material. It's a very, very heavy metal. Okay, if you have a giant ball of metal that has a huge mass, in its microscopic size, you know, let's say it has a diameter of, I don't know, a meter. There is a microscopic size. If it were true that material is being drawn to a high mass, then that would also happen with that ball of lead. In its microscopic universe, in its microscopic size. Of course, the material that would be drawn to lead would be tiny particles, right? But is that happening? Has anyone ever proved that to be true? No. If you pour water over that ball, it's not gonna stick to the ball, especially, I mean to that lead ball, especially if you turn it, if you rotate it. Have you ever seen what happens when you rotate a ball with water? Of course, the water is splashing into all kinds of directions because of centrifugal forces. And okay, a ball of lead may have a very, very thin layer or film of water temporarily stuck to itself. But we know that the water, over time, over the course of a few minutes, maybe half an hour, the water, all of the water will be flown down, okay, or will be evaporating because of heat, because of the sun. So it will not be stuck there like forever, like on a ball of earth, if we assume that the earth was a ball. But of course it's not true. So the physics don't align there at all. Gravity is not a force of itself. Gravity is just a sum of forces, and we describe the result of all of these forces in play as gravity. But it's much better to call it buoyancy for better understanding. And only later you can come back and call it gravity again once you understood that gravity is not a force that comes out of the middle of an object. Unless it's like something magnetic. Okay, but that's a whole other aspect of reality, of physics. Also magnetism, I mean magnetic materials don't attract everything. They just attract certain things, certain materials. Water is not magnetic. Okay, if anybody tries to claim in the future or whatever that water sticks to the ball because of magnetism, you know, it's just lies. And gravity is a Latin word, or comes from Latin, which means gravitas, or which is gravitas and means weight. It refers to weight, which is a different thing than mass. There is a distinction between weight and mass. Mass can be constant. That's the difference between the two. Mass can be constant throughout the whole universe, like the mass of an object. Doesn't matter where this mass is, but the weight that you measure can be very different depending on the medium it's surrounded by. So the weight of a stone decreases in water compared to the weight of a stone in air. Okay? Just letting the car pass. Oh no, it doesn't want to pass. Okay, back to it. You have a stone and it has a mass, and we don't change the mass, and the stone can go up or down in this universe and it will go through different medium. Okay, so the weight is just what we measure in a certain situation, depending on the medium. So that's why a stone weighs more surrounded by air than it weighs surrounded by water. Although the mass is always the same. And that is part of gravity, proving that it depends on the surrounding medium as well. You see, gravity is not alone. That's what people have to understand. Gravity does not come out of the center of some fake ball, Earth, okay, that creates the spherical shape of Earth. That's a false theory. Gravity only creates spherical shapes if the volume is very, very small and if it's flexible. You know, water bubbles, when water drops in air are flexible. Air bubbles in water are flexible. Soapy bubbles are quite flexible. Earth, in the end, is not very flexible. You see, um, it's not like a giant magnet that just draws materials to itself. Because again, we know that water is not magnetic. We know that there are materials that are non-magnetic. So why do they stuck to a ball? Of course, it's all false. It's not a correct theory. So I want to stop talking about the ball, come back to a flat Earth, because that's just the truth. And gravity works perfectly there because gravity is simply just a term that describes a result of many, many forces. An object is being influenced by forces, by air pressure, for example. And then these kind of things decide whether an object goes up or down. You have, for example, a helium balloon. It rises up through the air. Why does it rise up? Because it's less dense than the air. Helium is less dense. And depending on the volume of the helium balloon, it can carry a certain weight. Now, if you increase the weight that you want to carry, but you keep the volume of the helium balloon the same, it can happen that the helium balloon stops rising up. And that explains gravity. Okay? It now found its unique balance based on the helium in the balloon and based on the weight that the balloon is carrying. Okay? And it would just hover there. And the same with the moon. It's just hovering there based on its own properties, based on the surrounding that it's in, the medium that it's in. And what else can you talk about gravity? I mean, we have to establish the understanding that gravity is not a force of its own that is coming out of an object, from the center of this object. Okay? Why is a air bubble in water spherical when the volume of this air bubble is very small? Because of the water pressure that is pressing from all sides onto that air. Air is a gas. Okay? and that gas is something. It's not nothing, although it's transparent, but it's something, and it pushes against the water as well. While the water is pushing onto the air is pushing onto the water from outside. So it's actually escaping that center of itself. Okay? It's pushing against the water. So that is what creates a spherical shape. And then again, the higher the volume of that air bubble becomes, the less spherical it will become. And the best way you can compare this is with soapy bubbles. Soap has a certain property. It can create a surface tension, and it can catch air, or it can hold air inside. So inside the soap bubble is air, and it's surrounded by air. And so there is again a balance. Small soap bubbles are nicely spherical. The bigger these soap bubbles become, the less spherical they will be. They will deform. They will start to like float around. The top part is going left, but the lower part is staying somewhere else, and then they create these nice shapes in the air. Point is, they become less spherical. They would stay spherical if there was actually a force from within that bubble, but there is not. So the only reason why we get a bubble is because, for example, the volume is low, it's just a small bubble, and because the air pressure has the right amount, or whatever medium we're in, because a soap bubble cannot exist in water. You cannot create soapy bubbles underwater. Okay? That surface tension of the soap will be destroyed easily. However, in air it can exist. So all of these things come together. And for example, a soap bubble doesn't really rise up through the air. It kind of stays almost hovering in the way you're blowing it out, You change the direction. Let's say you point it straight down to your eye level, that soap bubble, because of the impulse, will just go forward and not really change its altitude, simply because there is air in the bubble and the bubble is surrounded by air, so there is a balance. Okay, it will not go up or down by itself. Maybe there's a little bit of wind in play. Then it could be that the soap bubble rises up or is being pushed down, depending on the wind, on the condition of the wind. So again, all of this could be summed up as gravity. What makes all of this happen? Gravity. Gravity is just a term. It's not a force of itself. It's just a word with which we're describing a whole bunch of things going on, resulting into one thing, which we observe. Okay? So if people claim, oh, gravity makes a spherical ball, then they are wrong. They don't know actually what gravity is. They are on the wrong page, because gravity is not a force that is coming out of the middle of the earth. So then you understand that Earth can simply be flat, doesn't have to be a ball, and gravity still exists. Okay? The existence of gravity is not bound to the shape of the Earth. However, the people who believe that gravity is a force of itself that comes out of the ball, they made gravity be depending on that ball shape. Or say it the other way around. The ball depends on that understanding of gravity, which is a false understanding. With the right understanding, you can also know that the Earth can be flat. Doesn't have to be a ball, and gravity still exists. Okay, and gravity is not pulling everything into one giant ball. Because then you would have to say, why are people not spherical? Why are stones not spherical? It's actually rare to find spherical stones. Why are trees not spherical? Spherical are things that, for example, expand like a fruit. For example, an apple can be kind of spherical. So it's pushing outwards. It's not a force that is pulling from things from outside inward. You see what I'm saying? So if a sphere is being created, for example, as a fruit, as an apple, then because something, what that is actually material, is pushing outward, is expanding. Okay? So that is also gravity. Okay, in a way. But it's obviously not a force from within the apple that makes that shape happening, pulling everything down to itself. No. The apple, as it is growing, is actually fighting the air pressure. Okay? And then pushing material into that shape, into the apple, from the branch of the tree, and that makes it spherical. But not all fruits are spherical again. Then all fruits would have to be spherical. So you see that there are many other things that come into play why shapes are spherical. So just saying, oh, the Earth is a ball because of gravity, I mean, that's just wrong. That's just not thought through. That's not science. That's far away from any observation. And it's just theoretical blah blah. Because a theory is only true if you can practice it, if it's practical. You can create a bunch of theories with animations and graphics and computers and make things fly from here to there, but is it practical? Does it actually align with God's laws? Okay? Then a theory is correct. I said it before, a theory must be scalable in practice, up and down, and then the theory is true. If a theory just works in a specific case, it's not true. Okay? So scalable, what does that mean? You have, for example, a microscopic version of a ball, a huge mass, and in that microscopic version you would have water sticking to that ball. You would have particles sticking to that ball. If it were true that gravity is a force that is coming out of the middle of this ball. But of course it's not reproducible, it's not scalable. What we're doing is basically downscaling. What we're doing is, or what I did just now was assuming the ball Earth. Okay, so assuming that Earth is a ball. Let's say it's real. Earth is a ball. Then we're downscaling it to a microscopic version. From macrocosm to microcosm. And it doesn't hold up, then it doesn't work. It's not true. Because what must happen is that you can make it in a microscopic way, then scale it up into a macrocosm, and when it aligns, it's true. Other way around, if you have a microscopic theory and you can scale it down to a macroscopic theory, and you can scale it down to a microscopic version, and it works, then it's true. But if that doesn't work, if you have a microscopic theory and the model, your microscopic model, does not represent that, it doesn't work, then of course the model does not represent the truth. Your microscopic level that you've created, your microscopic model that you've created, for example, an orrery, a planetary system, a ball Earth turning around itself and then turning around the sun, and then the moon turns around the Earth. Yes, in that model it can work, but when you upscale it and it doesn't hold up, it cannot represent the truth. Okay? Or, as I said, turning it around now, you have a macroscopic theory about the universe, and you're making a microscopic model of that, then the same physics have to apply. And when that doesn't happen, such as you cannot create a ball-shaped Earth in a microscopic way, to which oceans stick to, all of these things, then it's not true. Very simple. This is not some, because people think, oh, he's talking about microcosm, macrocosm, I don't want, what the heck is he talking about? Is he high as fuck or what? No, it's actually a very simple observation. You know, flat Earth, you're observing it exactly in that way. You're standing on a non-movable Earth. Sun and moon is moving above your head. All the stars, everything is above your head, moving. Why not accept that? Why turn it around? Why invert everything? Only if the inversion actually holds up, then it would be true. Then we would have to say, okay, it's not how we observe it actually, it's inverted. But the truth is that also, the way we perceive it also aligns with actual practical science. Okay? You have, for example, redshift. The sun has a certain color. Sunrise, sunset, the color changes. The color of the sunlight changes. For example, it goes from lunchtime, it has a very bright color, it's almost white, to sunset, becomes yellower, yellow, yellow until it's almost reddish. It becomes orange. Okay? And that's called redshift in physical terms, scientific terms. What is it? You have a light source that emits a certain color, and the further it moves away from you, the color changes. Not in truth, but to your perception. Okay, in truth, of course, the sun emits the same color wherever it is. If you were the sun, you would know, okay, I'm always emitting the same color. But to a man that is 10,000 kilometers away from you, your color will be different, will be darker, will be more redder. Okay, it moves in the spectrum, in the color spectrum. If you know the color spectrum, if you know the frequencies, then you know how it's moving. If you have, for example, a purple light source, then it's gonna be another color the further it moves away from you. If you have a blue light source that in truth is emitting blue light, then the further it moves away from you, and it has to move a lot. Okay, it has to move not just 10 meters, 20 meters, it must be in the thousands. Then you would realize a color change. However, the sun in the heliocentric model is supposed to be millions of miles away. So when we observe the sun and we're moving from one side of the earth to the other side of the earth during the course of a day, and that's just 12,000 kilometers of diameter, then you would not observe a color change. That must mean that the sun is much closer to Earth. It's a local sun, and that's what I talked about yesterday. I wanted to keep this about gravity. Now I started talking about local sun again. And I think the sound of the cars, I don't know if you hear it, maybe there's a noise cancelling going on, but to me it becomes annoying. Well, it's a live, it's not a recording, so sorry if outside forces change that whole experience. But back to gravity. Or maybe you want to know why exactly does the color change? In a minute. Maybe you want to know why the color exactly changes. And for this to witness, sun must be much closer than millions of miles, yet of course it must have a certain distance in the thousands, which it is, to actually observe a change in color. Okay? Again, the color changes because of wavelength, and wavelength defines the color of the light. So the way you can imagine this is you drop a stone into water, and then you know that shape that comes after that, the waves, you know. It's radiating away from the source. And close to the source, the waves are very strong in altitude. Okay? They have a strong altitude, and the further it goes away, it fades out. And that explains the wavelength and the change in color of light as well, because of course you have a light source, it's like a wave, and the closer you get to the light source, the closer you get to the truth of the color of the light. But the further that light source goes away, the wavelength changes. Basically the energy gets weaker, and that changes the color, the way you perceive it. Okay, because you're far, far away from that light source, and that's all. But again, if the sun is so, so, so far away from us already, like in the millions of miles, and then we're just changing just 12,000 kilometers from one end of the Earth to the other end of the Earth while we're rotating, then it has no effect on any color change, simply because there is a ratio here of just changing a few thousand kilometers compared to that distance of millions of miles. You see what I'm saying? If the sunlight hits you from 90 million miles with the color white, then you going from east to west or west to east, doesn't matter. You go in 12,000 kilometers from one side to the other, has absolutely no effect on that color. So back to gravity, because that's what I want to do. Gravity is more like buoyancy. People understand buoyancy better than gravity, but buoyancy is also just a term actually. Because buoyancy is, again, behind buoyancy is densities. And the same with gravity. You could say the same thing. Behind gravity is densities. And that equalizing of densities that is constantly going on in this world, it's balancing each other out. So each material finds its balance unless it is, I don't know, for example, caught up in a container. Let's say there's air under, or there's air in a bottle of whatever plastic, and then you put it into the ocean and you keep it there. Then of course that air does not or cannot seek its balance. But if the air is free, it will rise through the water back to its place where it belongs, because there is other air. That's the community of air. Okay, that's how you can imagine it. And it seeks that communion, and that's why it is rising up, because of densities. And then you have, for example, a water ball. They are filled with air, right? These balls that you can blow up of air, it just floats on top of the water because of buoyancy or because of gravity. You can say the same thing. Okay? But the more correct term here would be buoyancy, because it's like floating, right? But when we talk about a movement, like air bubbles rising through water, we would call it more like gravity. We would not say that's buoyancy. You see what I'm saying? But it's kind of the same thing. And gravity is often misunderstood as a force of itself. And that's a misunderstanding. To put it nicely, a misunderstanding. It's actually a deception. People are being deceived like this. And they come to all kinds of wrong conclusions. They think that, oh, because gravity is a force of itself, that's why the ball Earth exists. That's why the Earth must be a ball. But it's not true. Gravity is not a force of itself that comes out of the middle of any object. Gravity is the sum of forces that are influencing an object from outside the object, okay? And then inside the object is actually the contrary is happening. It's not a force that is going inside the object, but it's actually a force that is pushing outward, for example in the case of a stone, against the air. So again, they have it all twisted. They have it all turned around. This whole understanding about gravity. And then you come to inversions like, oh, people can float in space weightlessly. They don't understand that. They don't understand gravity, because gravity tells you that a human body always falls through gas. It only is weightless, close to weightless, in water, because the human body itself is made of 60% of water. Okay? So that's gravity. But in the wrong understanding of gravity, people can float in space in some sort of magic container that is called the ISS, which in truth, of course, is just a film production to deceive the people visually, because you cannot really mess with physics. You can only deceive people visually. So that's why people need to get back to the physics, to the physical world first. Lay down all your theories, like all your weapons. Lay them down, then come back to the physical world, and then build a theory from there. And then, of course, you're getting into theories that are scalable, upscalable, downscalable, that are truthful, that align with actual reality, and are not just some wish-wash in the head. Okay? You have no people floating in gas. That's for sure. And if there is gravity, just like an astronaut said, what keeps the moon there? Gravity. Then the same gravity would apply to a man walking on the moon. On that surface of the moon, it wouldn't jump around. It would just walk like we're walking on Earth. Because all of a sudden, okay, hey, there is a surface again. We can walk on that. Okay, we're falling through space, landing on the moon. We're just walking there, just like we would walk on Earth. That's actual physics. Okay, there is no special thing going on with the moon. These laws, these physics are repeatable and usable throughout the universe, whether you're here on Earth or on the moon or on the sun or further. They stay the same. These are God's laws, and nobody can mess with them. Okay? And theory, the word says it already, comes from theos, which is Greek, theos. Theo, which actually comes from Sanskrit, all the way back to that. It means God. So any theory that doesn't align with God is not true. With God's laws is not true. So you can come up with a bunch of theories, of course, based on visual deception, or spiritual deception, I don't know, lack of observation, lack of information. You can come up with a bunch of theories. And within the theory, things might be true. I mean, might work out. Calling it true is the wrong way. They might work out. You know, the heliocentric model makes sense within itself, but it doesn't represent the truth, the reality, the practicality, the practical reality. And so, if it doesn't work out in practice, the model does not represent the truth. You see, and people made up a whole theory in their minds and believe that, but there is only one theory, which comes from God. These are God's laws, nobody can mess with them. Nobody can actually mess with physics. The only way they can mess with people's minds is through the visual world, through vision, and also, of course, through words, these kind of things. But when you come back to observing physical reality, then you come back to the actual science that no man has created. These are God's laws, okay? And nobody floats up in space weightlessly. Nobody can go to the moon. That's the truth. Human body floats weightless in water. Here on Earth. Don't invert it, okay? People live in the inversion of life. A life of imitation and inversion. That's what people live. And they should stop all of that. Just let it be, right? Just look at the sky, it's turning, the sun is moving, the moon is moving, Earth seems very firm, stable. Let it be like this and you're gonna come back to the truth, okay? And with that said, I'm gonna quit that life.